So today I will discuss in this lecture some properties of vector product and a few problems based on that. So first of all, let me talk about that magnitude of cross product. Magnitude of cross product represents area of a parallelogram. So let us draw a parallelogram. So these are the two adjacent sides of a parallelogram, and using this let us complete a parallelogram. So I have completed this parallelogram, and let it is PQ, R and S. Say PQ represents a vector and PS represents P vector. So A and B basically they represents two sides of a and two adjacent sides of a parallelogram, and say theta with the angle between them, right? So what is the area of this parallelogram? The area of this parallelogram is equal to, say, let me draw a perpendicular from S2 over PQ and say it is T. So according to the formula of area of parallelogram, I can say that it is PQ into ST. Let me write down it as PQ into ST. Here what is ST? ST is the opposite side, means opposite to theta, so that's why ST upon PS can be written as sine theta. So therefore ST can be written as PS sine of theta, and PS is nothing but it is the magnitude of P vector, so it is P sine theta, and PQ is what? It is the magnitude of vector A, so it is B sine of theta. But if we try to look at A cross B, then A cross B is basically magnitude of A vector, magnitude of B vector, sine of angle between them, and n cap. So that means A cross B, if I take its magnitude, then it is A B sine of theta. So if I compare equation number 1 and 2, then what I conclude, that area of parallelogram is nothing what it is the magnitude of cross product, right? So thus I can say that magnitude of cross product represents the area of a parallelogram, right? Now let us have a look at its direction. Try to look at its direction. So since we know that it's A cross B, so it means if A cross B is lying in some plane, sorry, if both A and B both are lying in some plane, then let us assume that this is the n cap. So it's normal to, n cap is normal to plane containing A and B. So we can say that, keeping this in mind, that area is a vector quantity. Area is a vector quantity because the area swept by both A and B is basically this one, and it is represented by A cross B, its magnitude. So the normal to this plane is basically represents the areal vector. direction of aerial vector. So n cap is the direction of aerial vector or area vector. It is the direction of area vector. So we can say that area is a vector quantity, right? So let us do some problem relating to this cross product, and so let us do a problem. So for the given vectors, A and B, where A is 3i cap plus 6j cap plus 2k cap, and B vector is equal to 2i cap plus j cap plus 2k cap. Find number 1, angle between A and B. Then second, we have to find out A cross B, and third is the unit vector of normal to the plane containing unit vector of normal to the plane containing A and P. That's what we have to do. So let us talk about its solution. So to find the angle between A and B, we can either use cross product or scalar product. So this is the given value of A and this is the given value of B. So we can either, to find the angle, we can use either cross product or dot product, but it's better to use dot product. So that's why I'm using here dot product, because if I try to find out the angle using the cross product, then the mathematics involved is little bit more tricky. So better to use a dot product. So as I know that A dot B is equal to AB cos of theta, so that means this cos theta is equal to AB upon AB. So it is what? It is 3i cap, 6j cap, 2k cap into 2i cap, j cap plus 2k cap whole divided by their magnitude. It's 3 square 6 square plus 2 square under the root, 2 square plus 1 square plus 2 square under the root. So it's basically 3 into 2, 6 into 1 plus this 2 into this 2 divided by square root of 49 and square root of 9. So here it is 16 upon 7 into 3, so 16 over 21. So therefore cos of theta is equal to 0.7619. So theta is equal to cos inverse of 0.7619. So it is nearly equal to 40.3 degree. So this is the angle. Now I am interested to find out the A cross B. So to find A cross B, what I will do, it's A, it's cross B. It can be written as I cap, J cap, K cap and their components, right? So the components of first is this 3, 6, 2, and for the second vector it is 2, 1, 2, and I will solve this determinant. So what is it? I have considered this and remaining this part, so it is 6122 minus j, omitting this row and column, so it is 3222, then plus k, and here it is 3, 6 and 2, 1. So it's like this. So what I will do, it's I 12 minus 2, 6 to the 12 and 1 to the 2, and so 12 minus 2 minus j, 6 minus 4 plus k. I multiply 3 with 1 and 2 with 6, so it is 3 minus 6. So its value will be 10 I cap minus 2 j cap minus 3 sorry, it's I've written wrong. It's basically 3 minus 12. 6 2s are 12, so it is minus 9k. Okay, so this is the A cross B. Now we have to find out the unit vector. Third one is the unit vector normal to the plane containing A cross B. So unit vector plane containing is basically, this is second part. Let me talk about the third part. So it's plane containing this, so it can be written as A cross B divided by its magnitude, right? As we know that its value will be 10 I cap minus 2 j cap minus 9 k cap and divided by its magnitude. So its magnitude is 10 square plus minus 2 square plus minus 9 square whole under the root. So its value will be 10 I cap minus 2 j cap minus 9 k cap divided by 13.60. If I do little algebra, then it comes out to be this one. So this is the unit vector normal to the plane containing both A and B, right? So this is a problem which is based on this cross product, right? So that's all, and in the next lecture I will talk about few more problems on this cross product.